All right, so what I've done is I've divided each one of these. 225 divided by 3 is 75 cents. 450 divided by 6 is 75 cents. 675 divided by 9 is 75 cents. But don't worry about the one with the missing blank. Okay, but I determined that cost was the dependent variable because cost depends on number of pounds. That's why, like I said, if you weigh something like fruits and vegetables, the cost will depend on whatever the weight is. All right, so I have determined that it is proportional, so I'm going to put yes. This is proportional. All right, so I know it's proportional. I know what the constant of proportionality is. The constant of proportionality is just that constant number I kept getting. I'm sorry about this, the way this pen is writing. So it's 75 cents. So I'm going to make it look more like it has meaning. So it's actually 75 cents per pound. So it's whatever you're paying for, or this person is paying for, it's 75 cents per pound. All right, so how do you know, like, I know some of you are saying, how do you know the 75 represents the cents? I meant you have the amount of money, the cost, and then to put per pound. It's because when you write a rate statement, it's Y before X in a rate statement. So this number has to represent your Y. And whatever else you write has to represent your X. So this is the cost. So it's 75 cents per pound. All right, so to write an equation is in the form Y equals to KX. All right, so you're going to keep your Y. Although it represents cost, keep it because we're writing an equation. We don't have words in the equations. We have numbers and variables. K, the constant of proportionality is that's your K. So K is 75 cents. And keep your X. All right, so we have our equation. Okay, now we're going to go over here and try to fill in this missing value. Okay, so I have 1350 as a Y, therefore I'm missing an X. Okay, but 1350 is a Y. It's cost. So what I'm going to do is write Y, it's supposed to be a Y, guys, equals to 1350. So now instead of plugging in for X, I'm going to plug in for Y. Okay. So you're going to have 1350 equals to 7500 X. I'm writing slowly because that's about the only way I can get it to go in here where you can make sense of it. Now, solve for X. To solve for X, I need to get rid of 75 cents. Well, how do I get rid of 75 cents? Well, that's mashed together, which means multiplication. And to undo multiplication, we are going to divide. So you're going to divide both sides by 75 cents or 75 hundredths. These are going to cancel. And 1350 divided by 75 cents is 18. And now I need to know 18 what? Well, 18 is going to go here, which is under the word or in the column for pounds. So 18 pounds of something is going to cost us $13.50. Okay. All right, let's move on. All right, let's look at C. All right, C, we have some fractions, but it's okay. We know how to work with them. All right, so let's work with these fractions. All right, so I have hours, which is a unit of time, so it's X. Therefore, miles has to be Y. Okay. All right. Let me go back down to 1. Miles has to be Y. Okay, that's pretty good. All right, so we're going to take Y and divide it by X. So our Y is, someone can go 3 miles in a half an hour. So you're going to do 3, since it has fractions, instead of using the division bar, you're going to use the division symbol. 3 divided by 1/2. Well, I'm going to put this over 1, and I'm going to keep, change, flip, which means I'm going to multiply by the reciprocal. So I end up with 3 over 1 times, I don't know why that's there, times, flip that, 2 over 1. Well, 3 over 1 times 2 over 1 ends up being 6 over 1, or just 6. Okay, so now I got to check each one of these. All right, so now I'll check that one. Okay, now the next one, miles, and I'm going to have to do these where you can, it's going to take a little more work. I have 4.5 divided by, what is that, 3/4? All right, so I'm going to go ahead and convert 4.5 to an improper fraction. 2 times 4 is 8, and 8 plus 1 is 9. So that's 9/2 divided by 3/4. So then I'm going to keep, change, and flip, or in other words, multiply by the reciprocal. So you have 9/2 times 4/3. We end up with 36 divided by 6. And 36 divided by 6 is 6. Okay? So I've gotten 6 so far. I'm going to check this last one. 9 divided by 1 and 1/2. So I'm going to write 9 over 1. And I'm going to change this to an improper fraction. 2 times 1 is 2, and 2 plus 1 is 3. So 9 divided by 3/2. I'm going to keep, change, and flip. So I end up with 9 over 1 times 2 over 3 when I multiply by the reciprocal. That's 18 over 3, which is 6. Okay? So is it proportional? Yes, it is proportional because I keep getting 6. All right, now, so my constant of proportionality, which I'm just going to start writing K. K is 6. Let's see if I can write a better 6. K is 6. Now, it's really talking about 6 miles per hour. All right, so when I get ready to write the equation is in the form y equals to kx, again, where k, try this again. Undo. I don't want to erase all of that. Again, where k is equal to our constant of proportionality. All right, so it's going to be y equals to 6x. And then I just need to go back over here and fill in the missing value from the board, from the table. All right, so I have 3.5, but 3.5 relates to hours, okay? It's your x, it's your unit of time. So what I'm going to do now is substitute an x of 3.5. All right, we'll substitute an x of 3.5. All right, so that will help us to find y. Let me go back to this black. All right, so you're going to end up with y equals to 6 times 3.5. So I'm just going to write this as 6/1 times, I'm going to change this to a improper fraction. 2 times 3 is 6. 6 plus 1 is 7. So that's times 7/2. I end up with 42 divided by 2. And 42 divided by 2 equals 21. Well, 21 what? So you got the 21 that goes here. And it's in terms of miles. So in 3.5 hours, someone can go 21 miles. All right, and that's that. Let me go to the next page. All right, so this next page, we got more problems that look like word problems. And notice we got to fill the tables in. All right, so here we go. So we're just going to read and just kind of do what the problem tells us to do. It says 2 pounds of cashews cost $5. 3 pounds of cashews cost $7.50. And 8 pounds of cashews cost $20. So we want to show that the relationship between the number of pounds of cashews and the cost is proportional. So show that it's proportional. Okay, show the relationship is proportional. Yes, we got to check each one to make sure that the value we get after we divide is the same to show that. Okay, then it says, then write an equation. And then we're going to use that equation to find the cost of 10 pounds of cashews. All right, so first of all, I need my units because this table is blank. So I have 2 units. My 2 units are pounds. And what else is it talking about besides pounds? Well, it's talking about cost. So I have to decide which one goes in the X column and which one goes in the Y column. Okay, it's pretty easy because we've talked about already. Cost depends on the number of pounds. So cost is dependent. The dependent variable is always your Y. Therefore, the number of pounds is our X. Okay. Basically, again, I'm going to write cost depends on number of pounds. Since your cost is dependent, again, the dependent variable is always relative to Y. And then the independent variable is always relative to X. Okay? Your dependent variable is Y, your independent variable is X. All right, now I know how to fill this in. So 2 pounds costs what? 2 pounds costs $5. I'm going to do 2 and 5 in one row. Then we see that 3 pounds, let me do that in a different color. 3 pounds costs $7.50. And then we see that 8 pounds costs $20. And then we'll fill out the last part in just a little bit. We got one more part because it says we're going to use the equation to find the cost of 10 pounds of cashews. I'm going to go ahead and put that in. Use it to find the cost of 10 pounds of cashews. So I'm going to go ahead and put 10. Use to find the cost of 10 pounds. So 10 pounds is going to go right here. Therefore, I'm going to be missing that one, the cost there. All right, now, so I just need to check, make sure that the table is proportional. So I'm going to start off by taking our y and dividing it by our x. And so the y value is 5 divided by 2. And we're talking about cost, so basically it's $2.50. Then you're going to take $7.50, which is a cost, and divide it by 3, which is the number of pounds. So you have your $7.50 divided by 3, which is also $2.50. Now, if you're using a calculator, you're going to get 2.5, but I just add the 0, so it looks like money. The last one, 20 divided by 8. Well, if you take 20 and divide it by 8, you also get 2.5, so make it look like money. Basically, you're looking at $2.50. Okay, so is this proportional? Yes. This is proportional. Okay. All right, so it says determine the constant of proportionality. So instead of me writing out constant of proportionality, I'm going to use the variable that represents the constant of proportionality, which is K. So K is equal to $2.50. Basically, it's $2.50 per pound. Okay. Let's try to make it look better. All right, so it's $2.50 per pound. When you write the equation is always in the form y equals kx. So all you're going to be doing is replacing k, basically. So you're going to end up with y equals to 250x. Now, you don't have to put the 0. Some of you are just going to write y equals to 2 and 5/10 x. And that's absolutely fine if that's what you do. It's up to you. All right, so to fill in our missing value. So we have, for the missing value, we have 10 pounds. Okay? 10 is an x. So what I'm going to do is substitute an x of 10. So I have y equals to, we're just changing x, 250 times 10. And let me take that out of there because some people are going to think that's another x. I know y'all, some of y'all will do it. And what's the time sign, but I'm going to mash them together. Basically, when you multiply, you can just push this decimal one place over since it's by a multiple of 10. So basically, you're looking at 25. Well, 25 what? Well, 25 is talking about cost. So I'm going to put a dollar symbol on it. It's going to cost $25 for 10 pounds of cashews. Okay. All right, let's try this one. A cake recipe requires 3 1/4 cups of flour for 13 servings and 4 1/2 cups of flour for 18 servings. It says write an equation showing the relationship between the amount of flour needed per serving of cake. So I already see the word per. That's something I want to pay attention to, because this is a rate statement. Okay, for some reason it doesn't even want to write. There we go. All right. And then it says, then determine how much flour is required to make a cake that serves 28 people. Okay. So before the word per, and I'm going to write this out. Let me write it over here. You have amount of flour per serving of cake. Let me make that blank. Amount of flour per serving of cake. I'm just going to put per serving. Okay, so before the word per, that's like your Y. And after the word per is your X. Okay, so now I know how to set these up. Okay, so in the servings is going to go right here. And the amount of flour is going to go here in the X column. Excuse me, the Y column. That's your Y. Some people are just going to put, instead of amount of flour, some people are going to put cups. Okay, it's like cups of flour. All right, now let's fill in the table. So 3 1/4 cups of flour for 13 servings. So 13 3 1/4. And then it goes on to tell us we need 4 1/2 cups of flour for 18 servings. I'm going to have 18 servings with 4 1/2 cups of flour. And then we also know that we have, there's no other one, but we do know that we're looking for how much flour is required for 28 servings. So I'm going to go ahead and put 28 right here. And I can figure out that missing value in just a second. Okay, but first of all, let's see. Does this tell us that we need to determine if it's proportional like this one does? So I'm going to make sure everybody's reading. So on this one, we had to show that it was show that the relationship between the two was proportional. But on this one, do we need to show it? No, we just need to write an equation showing the relationship between the amount of flour needed per serving and then determine it. So we're not going to show the relationship, show that the relationship is proportional on this one. All right, so basically, if I'm not showing that the relationship is proportional, we already assume that it is. So if some of you are more comfortable showing that it is, go ahead, but you don't have to. What you can do to determine the constant of proportionality then is take any one of these rows and solve for and divide. So I could take 3 1/4, because remember it's Y divided by X and divided by 13. I'm going to put 13 over 1. And I would change this to an improper fraction. That's 13/4 times 1/13. So I end up basically with 13 over 42, over 52, sorry. And I can divide both of these by 13 if I want to simplify. So I end up with 1/4. Now you could have just canceled those two 13s out and then left with 1/4 if you wanted to cross cancel. All right, so now I could do 3 1/4 divided by 13, but you could have also gone with, and it's up to you which one you pick, 4 1/2 divided by 18. I'm going to put 18 over 1. It doesn't matter which one since we're assuming it's proportional, since I didn't ask you to show proportionality. But I'm just going with showing you that you could have picked either one. 9/2 times 1 over 18. So we'll end up with 9 over 36. Keep in mind, you need to multiply by the reciprocal there. I just flipped that one, 18 over 1. So divide both by 9. and we still get 1/4. So, I mean, it is proportional, but your constant of proportionality is 1/4. So therefore, your equation written in the form y equals to kx is y equals to 1/4 x. Now all I have to do is find this missing value right here. So this 28 is an x. So I'm going to put in an x of 28. So you end up with y equals to 1/4 times 28. I'm going to put it over 1. That's y equals to 28 fourths. Divide both by 4, or just divide by 4. It'll divide by 4 evenly. You get 7. 7 what? Well, 7 refers to the amount of flour, and the amount of flour is in cups. So I'm going to put 7 cups of what? Of flour is needed. Okay? And that's that. All right, let's go on to the next page. Last one, guys. Last page. All right, so let's take a look at... I don't want to do that. Let's take a look at this example. And it says Jeremy is saving money from a tutoring job. After the first 3 weeks, he saved $135. Assume that the situation is proportional. So we're assuming it's proportional. Then we're going to write an equation relating the amount saved, and that's the word to the number of weeks worked. Okay, remember if you see to or per, it kind of helps you out like with a rate statement. At this rate, how much would Jeremy save after 8 weeks? Okay, so let's just take a look at what we have. I'm going to start off with this part. Amount saved to the number of weeks. Okay, I'm going to write that out. All right, so there's the amount saved to the number of weeks. Okay, there's the word to. Well, what's before to? Amount saved, so that's like our y. What's after the word to? The number of weeks, so that's like our x. Okay? All right, so when we set this up, we know to divide y by x. So what was the amount that he saved? Well, so if we go back up here and look at the amount that he saved $135. It's going to take 135 and divide it by what? Okay, the number of weeks. Well, how long did it take him to save that? 3 weeks. So I'm going to divide by 3. And it's going to give me my constant of proportionality. 135 divided by 3 is 45. Okay, I'm going to make it make sense. So it's actually $45 per week is what he saved. But just keep in mind your K is 45. All right? All right, so now we write the equation, but the equation is always in the form y equals to kx, where k is your constant of proportionality. So we end up with y equals to 45x. All right, now, so we got the equation. So we've written the equation. And then it says, at this rate, how much will Jeremy save after 8 weeks? Okay, so 8 weeks. Well, 8 weeks is represented by the variable x. X is the variable weeks, okay, because this was the amount saved. And this was the x was the weeks. All right, so since it's 8 weeks, x is 8. So you don't have to have a table to do this. You can just reason this out. X is weeks, amount saved is Y. So if they gave you X 8 weeks, then that's your X, okay? So I'm just going to change my X to 8. So I have Y equals to 45 times 8. So we'll see how much he saved. So just multiply 45 times 8, and we get he saved, make it like money, $360. You don't have to put these two things on there, the dot 00. You just could have gone with $360, but put your dollar symbol on it. All right, it says, given that the following equations represent proportional relationships, identify that the constant of proportionality. Okay, because remember, all proportional relationships are in the form y equals to kx. Well, k is your constant of proportionality. But I want you to notice every time k was attached to one variable, what variable was k attached to? K was always attached to x. And then you may not have an x all the time, but the variable that's by itself, sorry, I'm trying to get this pen to right. The variable that's by itself is like your y. The other one is your x. So this one, k is clearly 3. All right, this variable that's by itself is like the d is by itself. It's on the side by itself. It's like your y. So I have a d and a t instead of an x and a y. I'm trying to stress to you, you don't have to have an x and a y. But d is by itself. It's like your y. This would definitely be your constant of proportionality. It's always attached to the other variable that's not by itself. Okay, so m is by itself. What's attached to this variable that's not by itself? Well, 3/5. So 3/5 is your constant of proportionality. All right, this says the equations below do not represent proportional relationships. I want to know why not. Why not? You know, you can tell me what is different. What is the difference from those that are above? Remember, those that were above were in the form y equals to kx. So what's different with these? Okay. Basically, they're not proportional. They are not in the form y equals to kx. They got some other stuff with them. Okay. This is like y equals to kx plus 2. And it's got something else stuck on it. Okay. Okay. That's not proportional. Why? Because of the plus 2. Okay. That plus 2 did it. Let me try to make that look better. Because of that plus 2. All right, what's wrong with this one? Well, this minus 28 doesn't have to be plus anything. This is like it's almost in the form y equals to kx minus 28. Okay, like we got a problem because it's minus 28 is the issue. Okay, and then on this one, the problem here is the minus 2 and 5/10. Basically, if it's proportional, it won't have plus anything added to it on it, or it won't have minus anything on it. Okay, all right, that's it, guys. And you got to remember, I think this video was broken up into 2 because it cut off on me. So you might see 2 videos attached to this lesson, all right? All right.